name is Al Hussein and we are Team Jaguar. We have chosen the topic of cloud computing for our Mindmap presentation, and we will be going over cloud computing in depth as well as exploring all the branches that you can see here. So, cloud computing is the delivery of different services through the internet. These resources include tools and applications like data storage, servers, databases, networking, and software. And now I will be going over our first branch, which is essential characteristics of cloud computing. So this cloud computing model is composed of five essential characteristics. The first characteristic here is broad network access, where basically capabilities are available over the network and access through devices such as cell phones, tablets, laptops, and workstation. This this access also includes content delivery networks, also known as CDNs, which refers to a distributed group of servers which work together to provide fast delivery of internet content. The CDN allows for the quick transfer of assets needed for loading internet content, including HTML pages, JavaScript files, images, and videos. Broad network access here also includes fog computing and edge computing. And in a nutshell, edge computing is data computation that happens at the network's edge in close proximity to the physical location creating the data, while fog computing acts as a mediator between the edge and the cloud for various purposes, such as data filtering. Moving on to the next characteristic, which is rapid elasticity. And capabilities can be elastically provided and released, in some cases automatically, to scale rapidly outward and inward, corresponding with demand. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be appropriated in any quantity at any time. And the next characteristic is measured service. Cloud systems automatically control and optimize resource use by leveraging a metering capability at a level appropriate to the type of service, such as storage, processing, or bandwidth. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and the consumer of the utilized service. And moving on to the next characteristic, which is on-demand self-service, where a consumer can individually provide computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. This includes serverless computing, which allows you to build and run applications and services without thinking about servers, cloud regions, or availability zones. And finally, the last characteristic is resource pooling, where the provider's computing resources are pooled to serve multiple consumers using a multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. There is a sense of location independence in that the consumer generally has no control or knowledge over the exact location of the provided resources. And that concludes my part, and now Zawash will go over service providers.
This is Zawash, and I'm going to talk about service providers on our mind mapping very briefly. So these days, we have a lot of companies which are coming with cloud services and performing better day by day. And in fact, we have maybe a lot of options to pick. We pick around seven service providers on our mind mapping: Azure, AWS, GCP, DigitalOcean, Salesforce, Alibaba, and IBM. So first of all, let's talk about a little bit about the cloud services, and then briefly I'm going to touch a couple of those service providers. So back in the day, we store our data on the hard drive. Still, we do that. The issue over there is those data on hard drives are not very reliable and secure. And as the drive can access by anyone, we need something more secure. And today we have that cloud computing service, which almost replaced search hard drive technology and came with a new concept called cloud technology, in which our data is stored in the cloud. And as I said, we have a lot of companies which provide cloud computing services, and they are very reliable. Technically, we have three cloud services, which is SaaS, PaaS, and IaaS. So SaaS stands for Software as a Service, which is a cloud service provided by the cloud company. And in this service, a customer provides software which can be either for a partial amount of time or for a lifetime. SaaS utilizes the internet and delivers the application to the customer. And most of the SaaS application, not all of them, but most of them does not require any downloads, as they can use directly through the web browser. For example, I can call Microsoft Office 365 as a SaaS or Google application. So the second one is PaaS, which is Platform as a Service, um, which is a framework for developer where they can create an application for customizing the applications. And for PaaS, I can call Amazon Web Server. Um, and the last one is IaaS, which is stands for Infrastructure as a Service, um, which provided by the cloud services provider. It helps customer to access and monitor things like computer networking and other services. In IaaS, the customer can purchase resources on demand rather than buying hardware, which is most expensive things and it's hard to maintain. For IaaS, I can call Microsoft Private Cloud or Amazon EC2. So here on service providers on our mind mapping, we have AWS, which is Amazon Web Services. Is a cloud computing platform that provides services such as compute power, database storage, content delivery, and many other functions which help to integrate a business. The thing about Amazon Web Services is it's very flexible, scalable, and reliable. And due to this, many companies are implementing it in their work. And there is no upfront cost, and the customer has to pay only for what they have used. It's one of the leading cloud services providing among all, and very famous. Many companies, um, medium or large companies, use AWS. Um, the next one I'm going to talk is Microsoft Azure, which is a cloud computing service as well, which is used for building, testing, deploying, and managing the application. This process is done in a global network for Microsoft Managed Data Center, and it's a private as well as a public cloud uh, platform. It uses virtualization, which different the coupling between operation system and CPU with the help of an abstraction layer known as a hypervisor. Um, and the last one I'm going to talk about is IBM Cloud Services. Um that one is such a as a platform as a service and infrastructure as a service. This cloud organization can deploy and access its resources such as storage, networking, and compute power with the help of internet. There are several tools which help the customer to draw on deep industry expertise. So, in the conclusion, cloud computing is helping a lot in businesses, whether it's a small, medium, or large. And these cloud service providers, companies provide storage, database, server, networking, and the software through which the business can increase. So customers can choose the company which is most suitable for their business and their requirement. It was very brief talking about service providers on our mind mapping. Hopefully, you enjoyed that. And that's it. Thank you.
Here we talked about the deployment models of the cloud computing services. As the cloud computing services has to be provided to different types of people, the deployment models defines 4 different ways to manage the underlying computer resources. So, first of all, the public model aims to provide the cloud services to everyone. Therefore, this model aims to reduce the costs of building the computer resources, and also it aims to maximize the scalability and availability of the computer resources. And in the opposite, the private model aims to provide the cloud services to a single person. Therefore, this model aims for very high security, and also this type of model will cost a lot more money than the first one. And besides these basic 2 types of models, here comes the third one, which combines the features of the previous 2, so this one is called a hybrid. So this model aims to lower the cost of building the computer resources while trying to provide a secure and private environment for each single user inside the organization. So a typical example of this model is like a company. So the company tries to provide a private environment for each developer for them to test their own services, while also the company wants to minimize the costs of building the entire computer resources. So this type of model aims for improved security over public, and also this model enhanced the flexibility of the management of the infrastructure, and also this model comes with a reasonable price. And the last type of the model is called community. So this type of model is designed for a group of organizations that serves the same purpose. So they require similar types of computing, and also they share the same types of concerns. So to save money, these groups of organizations can use the community model. So in this model, they have lower costs for building the computer resources, and also they have improved security and privacy and reliability, and most of all the ease of data sharing, because all the organizations in this group, they share the same purpose. They use the similar types of computings. So that's basically the 4 types of the deployment models.
Hello, hi, my name is Fernando, and I'll be talking now about service models on the cloud computing. The first model I'll be talking about is software as a service, or SaaS. It's a model that gives you quick access to cloud-based web applications. So in this case, the vendor controls the entire computing stack. So you have no control over your infrastructure. The user is not responsible for the hardware or any update. As these applications runs in the cloud, they're usually accessible over the internet through a web browser, and they're managed on a central location and hosted on a remote service usually. Does not require any installation or anything. So some examples of the services, software as a service. Some examples of the services would be Zendesk, Salesforce, Slack, Dropbox, Zoom, and there are many more applications out there. We can't have a whole list of these ones right here. And the next model I'll be talking about is Platform as a Service, or PaaS. It's essentially a cloud-based platform where you can develop and test and deploy your applications. It gives partial control of this infrastructure to the developers, and it helps them integrate web services and databases. It scales on demand, so you pay for what you really need to use, and it's also built on virtualization, so you don't actually have your applications deployed on bare metal servers, but there are virtualized services that give you the option to drop in your application there, and it will take care of all of the configurations and deployments for you. Some examples of these services are some famous ones like Heroku or AWS, Beanstalk, OpenShift, Magento. So basically you develop your applications, you drop into one of these platforms and takes care of everything for you. So as opposed of the next model I'm gonna talk about, which is infrastructure as a service. It's also based on virtual processing, computing of your resources over the cloud. But these resources are available to you as a service. So kind of as you need new machine or virtual server, just go into their website or use their API and say, oh, okay, here I want another server with X amount of CPU and memory. And the cost varies on consumption. So the more power you need, or the more space you need, the more you're gonna be charged on that. But it's also highly scalable. So on today's world, you can try to say like it's infinitely scalable, so you can scale your servers as much as you need, and it also gives you a better control over the infrastructure. So even though you can't go there and kind of touch the servers on the data center, you have full control of what is going to be installed. You can choose the operational systems and all the applications that you have installed there, and because of that, it's much more flexible. So you can basically use as your own server right there. So some examples of this are famous ones like AWS EC2, which is the compute engine, the DigitalOcean, the Google Compute Engine, and IBM. So that's kind of summing up the service models. And next I'm gonna ask Asad, gonna talk about practices on the cloud. Thank you.
My name is Asad, and today I'll be going over the practices section of cloud computing. So there are 5 major components to practices. There's DataOps, DevOps, GitOps, and DevSecOps. And lastly, cloud forensics. Out of the DataOps, DevSecOps, GitOps, and DevOps, I think the most prevalent are DevSecOps, DevOps. Yep. And for DevOps, there are 3 components to it. There's microservices, automation, CI, and CD. For GitOps, there's a component called infrastructure as a code. That's the main part to it. And then we have cloud forensics. And within cloud forensics, there are 3 different branches that it goes to. There's the process flow, some of the challenges faced by cloud forensics, and some of the tools that are used when performing cloud forensics. So I'll go over the tools first. So there are 6 different tools. I mean, there are different. There are many more tools as well, but these are the most popular, I guess you could say. So the first one is Ncase, and then there's FTK Toolkit. There's WinHex. There's FResponse, Frost, and Pores. Personally, I've used Ncase. Ncase is a great tool. And I haven't used other ones, but Ncase has been, when I used it, it was, it goes into really in depth. It's really good. And then some of the challenges faced by cloud forensics. They include accessibility of logs, physical inaccessibility, volatility of data, identification of evidence at client side, dependence of CSP trust, multi-tenancy, decentralization, absence of standard format of logs. Those are some of the challenges faced currently by cloud forensics when performing cloud forensics. So here's a cloud forensics process flow. So the 5 components to it has identification, evidence collection, examination and analysis, preservation, and then presentation and reporting. Identification is pretty straightforward. You identify, and then you do the evidence collection, which is collecting logs, cloud logs analysis. You get the logs of application logs, you get system logs, firewall logs, network logs, web server logs, audit logs, and also virtual VM logs. And then examination analysis, that's where you do physical memory analysis, and whatever, that's one of the components to it. And then preservation, and then obviously lastly you presentation reporting, whatever the results came back to from your analysis and your log collection. So those are the 5, or I guess you could say 5 different parts to practices that are being done within cloud computing.
Hello, my name is Yuan, and I will be present the cloud security issues and their solutions. While cloud computing models are full of advantages compared to on-site models, they are still susceptible to both inside and outside attacks. Therefore, cloud developers need to take security measures to protect their users' sensitive data from cyber attacks. We will start with an overview of key vulnerabilities of cloud computing technology, then take a look at the biggest cloud security challenges in 2021. Lastly, we will review practical advice on how to ensure the security of cloud-based solutions based on industrial best practice. Cloud technology is still being actively developed, and therefore it has many vulnerabilities that can be exploited by cybercriminals or malicious insiders. Let's look at the key cloud computing vulnerabilities that raise security concerns among cloud users. The first one is increased attack surface. There are many ways to attack cloud computing services, and attackers are constantly working on developing more sophisticated ones. However, becoming aware of at least the most common ones will help cloud developers design more secure solutions. Here is a list of the 10 most common types of cyber attacks performed against cloud users. The second one is data threats. Cloud users store different types of data in cloud environments, and a lot of that data contains sensitive information about users or business activities. This data is susceptible to loss, breach, or damage as the result of human actions and application vulnerabilities. It is obvious that a cloud service provider cannot prevent all data threats. The third one is cloud API vulnerabilities. Application programming interfaces allow users to interact with cloud-based services. However, vulnerabilities in APIs may significantly impact the security of cloud orchestration management, provisioning, and monitoring. Cloud developers need to implement strong controls over APIs. The fourth one is malicious insiders. Legitimate cloud users who act maliciously have many ways to arrange attacks or leak data in cloud environments. This threat can be minimized by implementing identity and access management technologies. The fifth one is shared technology vulnerabilities. Cloud computing involves the use of shared technologies such as virtualization and cloud orchestration. Therefore, by exploiting vulnerabilities in any part of these technologies, attackers can cause significant damage to many cloud users. Next, we have provider lock-in. Most modern cloud service providers make their clients dependent on their services with high switching costs. Many cloud users feel locked in when providers are not able to provide all the services they need. Next, we have weak cryptography. Although cloud providers use cryptographic algorithms to protect data in storage, they usually use limited sources of entropy to automatically generate random numbers for data encryption. For example, Linux-based virtual machines generate random keys only from the exact millisecond. This may not be enough for strong data encryption, as attackers also use strong decoding mechanisms to hack information. Therefore, cloud developers should think about how to secure data before it moves to the cloud. Last, we have vulnerable cloud services. While cloud computing platforms are designed as distributed systems of cloud services, these services have little protection against each other, which means an attacker can exploit vulnerabilities in any one cloud service to gain unauthorized access to data of legitimate users. Now let's look at the biggest cloud security challenges in 2021. For the sake of time, I will go over the first three challenges here since I already covered the rest. It is commonplace for organizations to assume that they are getting maximum protection simply by working with a cloud solution provider, but there is more to do. Compliance goes beyond international and federal regulations. There are also additional industrial mandates that must be addressed. My team member will get into that later. According to Cloud Security Alliance, 34% of companies are currently avoiding the cloud because they don't believe their IT and business manager have the knowledge and experience to handle the demands of cloud computing. This makes it one of the top 4 concerns business have in regards to cloud security. Cloud migration is happening in dose, but it has to be handled properly. Otherwise, it exposes the business to unnecessary risk. As a result, security professionals and IT pros are feeling overwhelmed by everything that's asked of them. The migration process should be broken down into stages to reduce the risk of critical errors that could corrupt data or lead to vulnerabilities. The dynamic nature of cloud services breaks the traditional security model used for on-site software. It is obvious that a cloud service provider is unable to ensure total security in the cloud. Part of the responsibility also lies with cloud users. While the best way to protect user data in the cloud is by providing a layered security approach, cloud service providers also should implement industry best practices to ensure the most level of cloud security on their side. Here are the 7 tips on how cloud developers can ensure the security of their cloud-based solutions. That's the end of my presentation. Let's move on to cloud computing compliance standards.
Thank you, and hello, my name is Edriss Ghafoori, and I'll be breaking down the cloud computing compliance standards. So first up, we have the NIST Cloud Computing Standards Roadmap, and this is a special publication 5.291. And within this one, the NIST Cloud Computing Standards Roadmap Working Group has surveyed the existing standards landscape for security, interoperability, portability, standards, models, use cases, all those good stuff related to cloud computing. And with this information and the current standards, gaps, and priorities are all identified within this specific publication. And next we have the NIST publication 516. And what this is basically it is the framework for cloud usability. So when you go through this document, you have stuff that has like the cloud standards, cloud from user experience, perspective, and it breaks down also the framework, what's capable, personnel, reliable, valuable, secure, all that good stuff that goes along with that. And what we have next is the FedRAMP. And FedRAMP is a Federal Risk Authorization Management Program. It's government-wide, provides just a standard to security system authorization and continuous monitoring for cloud services. Next we have the ISO IEC. It's Risk Technology Cloud Computing Vocabulary, and as it sounds, it's just a breakdown of everything with cloud, terms, definitions, and just basic foundation of cloud itself. Next is the ISO IEC. This is 17789 2014 as opposed to the 88, and this is gives more on the architecture of cloud computing and that aspect of it. Next we have the NIST Cloud Computing Reference Architecture Special Publication 5.292. And this basically just gives background on how cloud computing was adopted and how it was implemented in the federal government, and provides factors, whether technical or non-technical, and how it's proceeded to be done. And this 800 basically, it's a breakdown, I guess you could say, on the model of cloud computing and the more network technical aspect of it, and how that is all broken down. And we got a cloud computing synopsis and recommendations, special edition 846, and what this is explaining is basically what NIST's definition of cloud computing is, the benefits of cloud computing, and open issues with cloud computing. It gives a general overview as well. And lastly, the NIST Cloud Computing Forensic Science Challenges. What this is doing is just basically giving a summary of the research that goes into the forensic challenges of
responders when there's an incident that occurs and how they go about mitigating that.
Next, let me talk about a topic in cloud computing. It is about machine learning framework. So, cloud is a place to deploy various machine learning models to perform various tasks. So, for each task of the machine learning model, it will pose a problem that needs to be solved. For example, here in machine learning framework, we have four main problems that we need to deal with. In parallel execution, meaning that we need to perform multiple tasks in parallel. This is very benefit for the ML model training because we want the machine learning model to learn as much data as possible. And how could we do that? We do parallel execution by making the model learning multiple data samples at the same time. The second problem related to a framework, deployed machine learning framework in the cloud, is interactive query, which is how we can use machine learning model to interact with the data and returns the result directly. This is called interactive, and this is very benefit for doing some exploratory to investigating into the data and the model performance. Such a task is very beneficial for model design because in the model design we need to find some specific aspect of the performance on some specific data, and we want to have that result to be returned immediately. That is the meaning of interactive query. Next is streaming processing. Streaming processing here is that we want data coming in to be processed immediately. It does not mean that we need to return the data to the user like in interactive. Streaming here is the data in, process, data out, data in, process, data out. And it is very beneficial for the model deployment in some specific application. For example, in log mining, log here is the log that record some specific performance of the system. And in a very large system, the log generate continuously. We want to streaming processing the log so that we can detect the problem in real time or near real time. For example, detecting error using the machine learning model. Another aspect is the using machine learning model for monitoring the network. Because in a network with tons of traffic, we want to process those log information about the traffic in real time. And then we use that model to detect if something abnormal happened, like some intrusion, some malicious agent intrude into the system, or the network is being attacked. Those log files, it can process in a streamlined manner, can help to detect that in real time. And finally, we have a very traditional problem is batch processing, especially in the cloud in the early day. That is, we have a large amount of data. We need to process it. It doesn't need to be streaming in real time. It doesn't need to be interactive, but we need to process all of them. So this is the meaning of batch. And the problem related to that is large-scale image processing. For example, like image, satellite image or medical image, scan image. We have a large number of them. We want to process all of this information at the same time, and after some time, we want the result. So a machine learning framework that can handle this problem is also very beneficial. So to recap, we just discussed some specific types of machine learning framework on the clouds that can have to do with some specific problem like parallel, interactive, streaming, and batch processing. Next, let's talk about the machine learning API and current challenges. So first, let me introduce about machine learning API. API is Application Programming Interface, which is the interface that we can call and to ask the cloud provider that hosts the machine learning to perform some task and return the answer to us. Some, for example, like the API to detect some object, meaning that we will send an image to the cloud and the cloud will return a return to the answer is there a dog in the image? Is it an example of the API call? So what are the challenges related to the machine learning API? First one is a complicated input. That is, there are various ways to input to the machine learning model. However, the machine learning model only accepts one type of input. That is called the richest input. For example, machine learning model to detect objects can only accept a list of images in the JPEG format. However, in real world, we have a tons of way to input to the machine learning model, like videos in various format, and even in the list of image, there's also various format for that image. And those input is really dependent on the model. So the object detection model will need a list of image, but the language processing model will need to receive a list of words. So the input is complicated, and how to understand all of those input requirements for the API call could be a problem. Second one is a complicated cognitive semantic, meaning that the output from the machine learning model can have different meaning, and it depends on the task. For example, a image classification detection model, they will have the output of the model, and the output of the API will be a number that indicating the class. So for example, number 0 for dog, number 1 for cat. It's really depending on how the provider decide those number, meaning for those number. In other case, the output can be either from 0 to 1, showing the confidence for the model on specific tasks. Like if it's a model to detect a dog, the model will output a number from 0 to 1. So to understand all of the meaning of the output number of the model can be very complicated. And the third challenge is that it could be a complicated trade-off. We have various API that perform the same function, but each API will have a trade-off. For example, ingredient effort and performance. Some API will have a very high performance, but will require a lot of computation power or running time. Other API will run very fast, but have less accuracy. Correctly identify all of those differences between different API can be troublesome. Or the understandability versus the probabilistic answer. So some answer will be a real number ranging from 0 to 1, showing some confidence, for example. But to understand exactly what is that number and how much confidence for those number could be very different. For one model, 0.5 is a neutral, but in other 0.5 may be very less confident, and in the other model, again 0.5 will be very high confidence. Understanding all of these probabilistic interpretation is very troublesome. And another trade-off is that input transformation and accuracy. So input transformation here is that some API will receive a lot of different kinds of input, and it will try to transform those input. But typically, those type of model have lower accuracy than the model that receive only one type of simple input. And correctly differentiate between those API can be a problem. The next one is monetary cost versus performance. Some API have very high performance but cost a lot more than some other API, which may be free but usually have less performance, less accuracy. So how to address all of these challenges? Typically, we don't go into the detail of the solution here, but we will go over some introduction. There will be a two-way. First one is finding the bug, meaning that we try to identify some potential problem in each API. And the second one will be empirical study, meaning we will go through a lot of API on the market, analyze them, compare the differences in order to address all of these current challenges. So that's concluding my talk and also the talk of our group. Thank you for watching our video.